Alright guys, welcome to this page of the notes, and I got one more sample problem for us to kind of work through here when simplifying rational expressions, or expressions with rational exponents. I apologize. Rational expressions and expressions with rational exponents are two different things. So these are expressions with rational exponents, and you'll recognize this in a second. It actually is something we did in the previous section. It just looks a little different because I've written it with rational exponents instead. But we know what the 1/2 power means. We now know the 1/2 power just simply means a square root. So let's go ahead and rewrite this, and then you should recognize it as something we did in the previous section. So I rewrite this guy so that my rational exponents are now radicals. This would be the square root of m minus 1 and the square root of m plus 1. Well, what we saw in the previous section, section 5 of this chapter, was anytime you have a radical in the denominator, right, what we're going to do is we'll multiply top and bottom by the conjugate of the denominator. So we'll multiply top and bottom of this quotient by the square root of m minus the square root of 1, because that's the conjugate of the square root of m plus 1. The conjugate is the square root of m minus 1. So let's go ahead and do that. The square root of m minus 1 and then the square root of m plus 1, and we'll multiply top and bottom by the square root of m minus 1 over the square root of m minus 1. Again, what we learned in the previous section was you just simply multiply top and bottom by the conjugate of whatever the denominator is. And when we say conjugate, all we mean is you just change the sign, right? So since I have a square root of m plus 1, multiply top and bottom by the square root of m minus 1. But this requires me to FOIL. So we'll go ahead and FOIL this guy out. Square root of m times the square root of m is going to be the square root of m squared. And then I will have the square root, a negative square root of m minus square root of m minus a square root of m. And negative 1 times negative 1 is a plus 1. That's my numerator. Now remember, what we said is in the denominator, the reason I multiply by the conjugate is so the middle terms drop out. Now I won't assume that. I'll show you again how it works, but you should remember from the previous section, those middle terms are just going to cancel out. That's why we multiply by the conjugate. So a square root of m times a square root of m will be a square root of m squared, just like it was above. Then I'm going to have a square root of m times a negative 1, which would be minus square root of m. But then I have a positive 1 times the square root of m, which would be a plus square root of m. And like I just mentioned, and hopefully you remember, minus the square root of m plus the square root of m, those guys cancel each other out. Then positive 1 minus 1 gives me a negative 1, and we're almost there. Our final answer is going to be this. Square root squared cancels each other out. That leaves me with an m. Minus the square root of m minus the square root of m is minus 2 square roots of m plus 1. So that's my numerator. The denominator, like I said, those middle terms cancel each other out, so they just go away. Square root of m squared, the square root, the square, cancel each other out. You're left with just an m. And then, of course, my minus 1. And that's going to be as far as you can go. I don't have any negative exponents. I don't have any radicals in the denominator, right? So I don't need to, I've already rationalized, right? I had a radical in the denominator, so we did all of this work to rationalize the denominator, to get that radical out of the denominator, which is exactly what we did. I can't get anything to cancel top and bottom because there aren't there's no GCF other than a 1 that I can pull out of all of those terms. So this is as simplified as it gets. And again, this was just a problem from the previous section where you have to multiply top and bottom by the conjugate of the denominator. It was just slightly disguised because instead of giving it to you in radical form, I gave it to you as a rational exponent, which was the whole point of this set of videos, this section in the notes dealing with rational exponents. Guys, thanks so much for joining me for this set of videos. Hopefully rational exponents make a lot of sense when it comes to rewriting them and simplifying. I had a lot of fun doing it with you, and I'll see you guys next time.